Welcome friends, this is my 7th video on differentiation for the class 12 students of mathematics, of science and arts. We have already solved some examples from exercise 1.1 of the topic differentiation, and there we have solved examples like this where the function y is equal to cos of x square plus a square, or y is equal to this kind of examples were discussed, and we used to differentiate them with respect to x and then find dy by dx. But this time we shall see some examples slightly different, where we'll have to find out derivatives where the functions fx, gx, f dash x, g dash x, these kind of notations will be used in the examples. So such examples we haven't tried yet. So in this video we shall see the problems on chain rule involving notations fx, gx, f dash x and g dash x. Also in the end we shall see one activity which is similar to this. This is the given activity in the exercise 1.1 in the textbook, where the examples are solved in the same manner, but there is a hint basket in the end which has to be used to fill up these blanks. I'll take such activity, similar activity, at the end of this discussion, and but I will not use this hint basket. You can solve this activity at home as a homework. So let us start our discussion for today. We have solved examples on chain rule, but this time we shall use a new notation, which is actually a fundamental notation, but we are not used to it. So let us see this set of examples for understanding the notational difference. How do you write d by dx of fx? D by dx of fx is written as f dash x. D by dx of gx in the same way. You can understand it is g dash x. F is a function of x, so directly derivative is f dash x. Now here the slight difference is there. F of gx, d by dx of f of gx, that means derivative of f of gx with respect to x. It's not just f dash gx, it is f dash gx to start with, and then into, just like see, d by dx of fx is f dash x, so d by dx of f of gx is f dash gx into d by dx of replacement of x. When you compare these two functions, f of gx and f of x, when they are compared, x is replaced by gx. So what do you write after differentiation? F dash gx into d by dx of replacement of x. Replacement of x is gx, so d by dx of gx, which means it is equal to f dash gx of gx, which is f dash gx into d by dx of gx is g dash x. What about this? I can leave it up to you, but still you can answer it. It's d by dx of g of fx, just like d by dx of gx is g dash x, so d by dx of g of fx is g dash fx into d by dx of replacement of x when these two are compared. G of x and g of fx, when they are compared, x is replaced by f of x, so d by dx of f of x. And what is d by dx of f of x? D by dx of f of x is f dash x. So in the final form I may write this as g dash fx as it is, g dash fx into d by dx of fx is, so d by dx of g of fx is g dash fx into d by dx of fx, which is g dash fx into d by dx of f of x is f dash x. Now this is just one step ahead, g of h of fx, and you have to find derivative of that. So d by dx of g of h of fx is, how do you write it? G dash h of fx to begin with into d by dx of what? You compare this function g of h of fx, g of anything is compared with g of x, and in that case what we do is we replace x by h of f of x. So d by dx of replacement of x is h of f of x, which means it is equal to g dash h of fx into d by dx of h of fx. H of fx's derivative is h dash f of x into d by dx of you compared h of fx with h of x, so x was replaced by fx, so d by dx of fx. H of fx's derivative is h dash fx to begin with, and then into d by dx of fx, because you compared this h of fx with hx, so x was replaced by fx, so d by dx of fx. And in the next step we write this as the same in the previous step, and then into d by dx of fx is f dash x, because now fx is a standard function, so derivative is directly written. So this should be known to us before we solve some theoretical questions or the problems involving the notations fx and gx. Let's try to answer these. D by dx of f of root x. What is your answer? D by dx of f of root x is, you compare this with f of x, so derivative is f dash x, so it will be derivative will be f dash root x in the beginning, then into d by dx of what? D by dx of, you compare this f of root x with f of x, so x was replaced by root x, so d by dx of root x, and you must know that d by dx of root x is 1 upon 2 root x, so this will be repeated, f dash root x into d by dx of root x is 1 upon 2 root of x, that means f dash root x divided by f dash root x into 1 upon 2 root x. Then d by dx of g of sin x, you compare this g of sin x with g of x, so replacement of x is sin x, so remember that. Now derivative of g of sin x is g dash sin x into d by dx of replacement of x when you compare g of sin x with g of x, so x was replaced by sin x, so d by dx of sin x. And in the next step I shall write this d by dx of sin x, which is cos x, so g dash sin x into cos x, g dash sin x into cos x. Now what about this? D by dx of f of g of tan x. You can answer this. It is f of g of tan x is compared with f of x. So f of x's derivative is f dash x. So d by dx of f of g of tan x is f dash g of tan x into f dash g of tan x into d by dx of replacement of x is g of tan x. d by d of g of tan x, d by d of g of tan x is g dash tan x into d by dx of, when you write d by d of g of tan x, it is g dash tan x into replacement of x derivative, that is d by dx of tan x. I am doing it a little bit directly, but you can understand this. This is f dash g of tan x into g dash tan x and into finally d by d of tan x is known to us, it is sec square x. So in this manner we can answer this kind of derivatives. This is one of the questions in the exercise 1.1. See this table, we have x, fx, gx, f dash x and g dash x in the row, and then the values are written. It is read as at x is equal to 2, f of x is 1, that means f of 2 is 1, g of 2 is 6. Put x is equal to 2, you will find g of 2 is 6. What is f dash 4? What is f dash 4? This is f dash x. So f dash 4 should be, x should be replaced by 4. So f dash 4 is, you can see, it is 5. F dash 4 is 5. F dash 6 is minus 4. G dash 2 is, g dash 2 is 4. So you can understand these values. Now we are ready to answer this. This is the question. If r of x is f of g of x, then find r dash 2 in a derivative of r at 2. So answer this. Answer starts with, we have to find r dash 2. So we have to first find r dash x. So to find r dash 2, therefore we try to find r dash x first. Then we shall put r x is equal to 2 in it. So r dash x means what? D by dx of rx, isn't it? R dash x is d by dx of rx. What is d by dx of rx? D by dx of, what is rx? Rx is f of g of x, f of g of x. So d by dx of rx means d by dx of f of g of x. Now how do you write d by dx of f of g of x? F of g of x's derivative is f dash g of x, which we have practiced earlier, into d by dx of what? D by dx of g of x. So how do you write it? D by dx of f of g of x is f dash g of x when you compare this f of g of x with fx. So fx is related to f dash x. So f dash g of x into d by dx of replacement of x. Replacement of x is g of x. So d by dx of gx, which in turn is f dash g of x into d by dx of g of x is g dash x. Now we are ready to answer our question r dash 2. What we know is r dash x. So remember this formula for r dash x. This is the formula we got for r dash x, and we shall use x is equal to 2 here so that we can find r dash 2. So put x is equal to 2 here, here and here, and what will you get then? R dash 2 therefore is equal to, r dash 2 is equal to f dash g of 2, f dash g of 2 into g dash 2. Now what is that? Slowly you will find this. G of 2 you are knowing from the table. G of 2. Look at g of 2. This is your g of x. So there you will find g of 2, g of 4 and g of 6. What is g of 2? G of 2 is 6. So I shall write f dash, then value of g of 2 is, g of 2's value is 6 into g dash 2. G dash 2 will be found from the column g dash x. So g dash x is this. So g dash 2 is required. So at 2 g dash x is 4. So g dash 2 is equal to 4. Now what is f dash 6? What did we do here? G of 2 is been put. G of 2 is 6. G of 2 is 6. That is been written here. And then g dash 2 is written. G dash 2 is 4. That is also written. Now f dash 6 is required. F dash 6 will be found from here. F dash x. F dash 6 is required. F dash x is this. So f dash 6 is what? Minus 4. This is minus 4 multiplied by 4. So if you multiply these two, you will get the answer minus 16. So r dash 2 is equal to minus 16. This is one example on activity. In exercise 1.1, you will be given one question on activity. This is a similar one. You can understand what is done in such kind of examples, and then you can solve the activity in the textbook on your own. Let us see. Let fx is x cube minus 1, gx is 2l is 2x plus 3. What is f of gx? That has to be written here. G of fx. Again, you have to find it out. F dash x. Looking at this function, you can find the derivative. G dash x. From g of x, you can find this derivative. Then derivative of fx, you can read this. Derivative of f of gx with respect to x in terms of fx and gx. That has to be written. And then the same thing is written in the symbolic form. Derivative of f of gx with respect to x. That means d by dx of f of gx. Just this is written in words and this in the symbols. We have to write the expression and then simplify it here. And finally, you have to find this derivative's value at a particular point x is equal to 0. So d by dx of f of gx, which you have found here, but we have to find its value at x is equal to 0. So we shall put x is equal to 0 in that expression of d by dx of f of gx and find this value. So let us begin from f of gx. How do you write f of gx? F of gx means you practiced it in 11th standard. It is f of gx is f of, you have to write what is gx in it. Gx is 2 raised to x plus 3, which means it is equal to, now f of 2 raised to x plus 3 is f of x's formula is given to you. F of x is x cube plus x cube minus 1. So f of x is x cube minus 1. So f of 2 raised to x plus 3 is, think about it, it should be 2 raised to x plus 3 whole cube minus 1. Just remember this definition. If you use x as input, what is the output you get? Cube of x minus 1. So inputs cube minus 1. If you put input as x, what is the output? Inputs cube minus 1. So your input in this case is 2 raised to x plus 3. So inputs cube minus 1. In the same manner, 2 raised to x plus 3 is g of x. So you will have to use this here. G of f of x is g of, what is f of x? F of x has to be written from the definition. It is x cube minus 1. So g of f of x is written as g of x cube minus 1. And g of x cube minus 1 will be found from g of x's formula. G of x is 2 raised to x plus 3. So if you use x as input, what is the output? When you put x as input in g, you get 2 raised to that input plus 3. So here the input is x cube minus 1. So 2 raised to that input, that is x cube minus 1, and then plus 3 by this formula. So these are the two values which we wanted. The two blanks are filled up. Now f dash x. Now f dash x is written from the derivative from fx. Derivative of fx, that means derivative of x cube minus 1. That should be written here. So f dash x is, what is derivative of x cube minus 1? It is 3x square minus 1's derivative 0. So it is just going to be 3x square. Now g dash x. Now g dash x, this is gx. So d by dx of 2 raised to x plus 3. D by dx of 2 raised to x plus d by dx of 3. D by dx of 2 raised to x is 2 raised to x log 2 plus 3's derivative is 0. So we can finish it as 2 raised to x log 2 only, plus 0 can be ignored. So far we have filled up these 4 blanks. Then the next part, derivative of f of gx with respect to x in terms of fx and gx. So basically they are asking you this. Derivative of f of gx is f dash gx to begin with into d by dx of what? D by dx of f of gx is f dash gx into d by dx of gx, which means it can be simplified a little bit further. F dash gx into d by dx of gx is g dash x. That's what we want to find out in this step. Just you write this d by dx of f of gx in terms of fx and gx. That's what we have done here. You can fill these values of gx as 2 raised to x plus 3 and g dash x as 2 raised to x into log 2, etc. in the next step, because now that is expected in this step. So there is a small difference between these two steps. Here d by dx of f of gx means this value which we found, that has to be simplified. F dash gx is equal to f dash as it is, then gx is where gx means what? Gx means 2 raised to x plus 3 into g dash x. What is g dash x? G dash x is 2 raised to x log 2. So what have you got so far? F dash 2 raised to x plus 3, which is f dash gx. F dash is written there. Gx means 2 raised to x plus 3, as you can see here. And then into g dash x is 2 raised to x log 2. That is also written. You can simplify it again. That as f dash 2 raised to x plus 3 means what? What is f dash x? F dash x is 3x square. So what happens to this f dash 2 raised to x plus 3? So if you use x as input, what is the output of f dash? 3 into that input square. So 2 raised to x plus 3 is the input. So f dash 2 raised to x plus 3 should be 3 into that input square, that is 2 raised to x plus 3 square only. So 2 raised to x plus 3 square into 3. That's how you get it. And then into 2 raised to x log 2 is repeated. So 3 into 2 raised to x plus 3 whole square into 2 raised to x into log 2. This is what we get for f d by dx of f of gx. Now finally, I shall use this space for next step. I shall write that answer here. What do we get here? F dash 2 raised to x plus 3. It is f dash x's formula 3 into 2 raised to x plus 3 square, and then into 2 raised to x log 2 as it is. Now in the last step we have to write this value here, but we will use x is equal to 0 in it. This d by dx f of gx is same thing with us, but at the value x is equal to 0. So imagine this 0, 0, and what will happen then? 3 into 2 raised to 0, 2 raised to 0 plus 3 square into 2 raised to again 0 into log of 2. And you can simplify this, because now you are knowing most of the things. 2 raised to 0, this matter is going to be just 1. 2 raised to 0 again 1. So it's going to give you 3. F of gx as x equal to 0 is 48 log 2. So in the same manner you can answer the activity given in the exercise 1.1 in the textbook. This is the activity given in the textbook. It is very much similar to what I solved now, but I didn't use the hint basket, which gives you the possible answers. that can be used to fill up these blanks. For example, this is f dash x has to be equal to, now what is your fx? Fx is x square plus 5. So f dash x is going to be 2x plus 0, that means 2x. So that is that 2x there, 2x. You can put this value or use this option 2x and put here. So like that you can fill up these blanks and complete this activity at home. So today we discussed the problems on chain rule, especially the examples involving notations fx, gx, f dash x and g dash x. In the next video we shall see a new rule of differentiation called derivatives of inverse functions rule, and also we shall solve some examples on the derivatives of inverse functions. So that is it for today. Thank you.